Hi, my name is Patrick Reagan. The OSI model transport layer goes into more depth of the transport layer of the OSI model, including the various technologies used in the transport layer. The transport layer is responsible for providing reliable data transfer services to the upper layers of the OSI model. It ensures that data is transferred from the source to the destination without errors and in the correct sequence. The unit of measurement used in this layer is sometimes referred to as segments. Transport layer functions include segmentation and reassembly, where large data messages received from the upper layers are divided into smaller manageable segments on the sending computer and reassembled into the original message on the receiving end. Connection-oriented communication establishes, maintains, and terminates dedicated virtual connections between devices to ensure that data is delivered in the correct order and without duplication. Connection is established between the sender and receiver before data is sent. It performs handshaking, flow control, and error checking. It offers guaranteed delivery as it ensures that data reaches its destination and that lost packets are retransmitted. After data transfers is complete, connection is terminated. An example is Transmission Control Protocol, or TCP. Connection-oriented communications uses acknowledgments to ensure reliable data delivery, meaning the receiver sends an acknowledgment message back to the sender to confirm receipt of data segments, enabling retransmission if necessary. In connection-oriented communications, the packets of a connection may not necessarily travel the same path, and packets may arrive out of order, which will have to be placed back in order. You can think of a connection-oriented communications would be similar to the parcel delivery service, such as FedEx or United Parcel Service, where the packet is tracked and delivery is verified, and often must be signed by the destination when it's received. Connectionless communication provides connectionless services where each segment is treated independently without establishing a dedicated end-to-end connection. It is faster than connection-oriented communication because it does not perform handshaking, flow control, or error checking. Packets are not numbered and may arrive out of order. It is considered unreliable because there's no mechanism to verify that the packets were delivered. In other words, no guaranteed delivery. An example would be User Datagram Protocol, or UDP. While a connectionless communication is considered unreliable, on a stable network, packets will most likely be delivered. You can think of connectionless communications being similar to the post office, where millions of items are mailed and delivered every day, but items are not tracked and verified that they actually made it to its destination. Flow control manages the rate of data transmission between sender and receiver to prevent overwhelming the receiver, such as using buffering and windowing. Buffering is a temporary storage of data while it's being moved between devices or between a device and an application. Buffers can help manage data flow, regulate data transfer rates, and improve the user experience by temporarily storing incoming data so that it can accommodate fluctuations in internet speed, network congestion, or latency. The windowing process allows the server to control the flow of segments it receives during a TCP transaction. The server has been overwhelmed with segments from other clients, then it could have been delayed sending acknowledgments, thus preventing the clients from sending more segments. Sliding window mechanisms is where the sender adjusts its rate based on the receiver's advertised window size, ensuring that the sender does not overwhelm the receiver. Credit-based flow control is a network communication mechanism where a receiver sends credits to a sender, indicating how much data the receiver can currently accept, essentially preventing the sender from overwhelming the receiver with data by ensuring there's enough buffer space available. The sender only transmits data when it has available credits. Once the sender transmits data, it consumes credits, and the receiver sends new credits back when it has processed the data and has space in its buffer. It is often referred to as back pressure mechanism, where the receiver controls the sending rate based on its capacity. Credit-based flow controls use a bigger buffer space available at the receiver, which will dictate how much data can be sent before needing acknowledgement that the data was received properly. Error control ensures that data is delivered without errors, including using various techniques, including checksums. Checksums is a small piece of data calculated from a larger block of data used to detect errors that may have occurred during transmission or storage, essentially acting as a way to verify the integrity of the data by checking if it has been altered or corrupted. It's like a digital fingerprint for a file or dataset. If the values are different from when the packet was sent and when the packet was received, the data is changed, corrupted, or tampered with during transmission. Acknowledgements is a packet that is sent back to the sending device saying that the packet or packets have been received. If the acknowledgement has not been received by a certain period of time, the data will be resent. If the data is corrupted, a message will be sent back to resend the data. Multiplexing allows multiple applications to use the same network connection simultaneously by assigning unique port numbers to different applications, and demultiplexing is done at the receiving end that directs incoming data segments to the appropriate application based on the port number. End-to-end communication provides logical communications between application processes running on different hosts so that the data is delivered from the source application to the destination application reliably. Every time a TCP/IP host communicates with another TCP/IP host, it will use the IP address and port number to identify the host and service or program running on the host. This enables multiple services run simultaneously on the same computer and receive data intended just for them. A TCP/IP port number is a logical connection placed by client programs to specify a particular server program running on a computer on the network defined at the transport layer. The source port number identifies the network application or service that sends the data, and the destination port number identifies the application that receives the data. Port numbers are from 0 to 65,536. There are two types of ports, TCP and UDP, that are based on their respective protocols. Today, the very existence of ports and their numbers is typically transparent to the users of the network, as many ports are standardized. The Internet Assigned Numbers Authority manages port numbers from 0 to 65,535. Well-known ports are port numbers from 0 to 1023 that are used by common services like HTTP, HTTPS, and DNS. Registered ports are ports in the range of 1024 to 49,151, which are used by applications that are less common but need specific ports to work. These ports can be registered to prevent duplication. Examples of applications that use registered ports include Remote Desktop Protocol, Xbox Live, and games for Windows, and IBM Lotus Notes and Domino. Dynamic or ephemeral ports are ports in the range of 49,152 to 65,535, which are assigned temporarily to applications when they need to establish a connection. These ports are not assigned, controlled, or registered. When you connect to a web server to open a web page, you send a request to port 80 and/or port 443. When it gets to the server, the port 80 and 443 indicate the web services running on the server. When the web server responds, it will assign a dynamic port to the requesting computer. Each requester will have its own port, so it can keep track of multiple requesters. This allows the service and network application to communicate simultaneously with multiple clients. A socket is a virtual endpoint of a two-way communication link that acts as a communication channel between two applications on different devices, allowing them to exchange data over a network. Essentially, it's a logical address that combines an IP address and a port number to uniquely identify a specific application on the host, enabling data transfer between applications on different computers. Sockets facilitate two-way communications between applications by establishing a connection through which data can be sent and received. Sockets can utilize different network protocols like TCP for reliable connection-oriented communications or UDP for less reliable connectionless communications. For example, TCP port 53 and UDP port 53 assigned to the same IP addresses are two separate sockets. In your browser, when you type http:// web server 01, you automatically go to TCP port 80 because the default port for HTTP is port 80. This is equivalent to http:// web server 01:80. However, when you type in http:// web server 01:8080, you're going to TCP port 8080. TCP is inferred because you're using the HTTP protocol. Running the netstat command, which is shown on the left, and opening Windows Resource Manager will show you the sockets. In the Resource Manager, you can see that this machine is talking to several servers using port 443 remote port, which are assigned different dynamic ports as shown in local port. A WinSock or Windows Socket is a specific Windows Application Programming Interface or API used to create and manage network sockets on a Windows operating system. Essentially, WinSock provides the programming tools to interact with network sockets on a Windows machine. It's based on the Berkeley Unix Sockets interface. Layer 2, Data Link Layer, primarily handles error detection by adding a checksum like CRC to data frames, notifying the sender if errors occur during transmission. It uses cyclic redundancy check or CRC to check for data corruption during transmission on the same local network or physical layer. Layer 2 typically only detects errors and signals to the sender to retransmit the data if necessary, not actively correcting the errors itself. Layer 3, Network Layer, focuses on routing packets across networks, relies on protocols like ICMP, Internet Control Message Protocol, to diagnose and report errors, but doesn't actively correct them. ICMP messages report errors like destination unreachable or time exceeded to the sending device. Layer 3 can adjust routing paths based on error information received through ICMP to find better routes. Layer 4, or Transport Layer, is responsible for full error correction, which means re-requesting data segments if errors are detected, ensuring reliable data delivery across the network. You'll notice that Layer 2 Data Link Layer and Layer 4 Transport Layer both have flow control, error control, and multiplexing. At the Data Link Layer, flow control, error control, and multiplexing occur within the same network segment, such as the switch or network interface. For flow control, Ethernet can send a pause frame to instruct the sender to stop transmitting for a specified period. At the network layer, flow control is less common, but some congestion control and quality of service can be considered as part of flow control. At the transport layer, flow control, error control, and multiplexing are critical for ensuring reliable and orderly data transfers between end-to-end devices regardless of the underlying network. Now, firewalls typically operate at the following layers. Layer 3 network layer can filter packets based on IP addresses. Layer 4 transport layer can filter packets based on port numbers, layer 4, which usually indicates which protocol. Layer 7 application layer has advanced firewalls that can provide more detailed inspection of application data, such as the HTTP header and payload, to detect more complex threats. Question: which layer of the OSI model is used to ensure messages are transmitted and received to their destination and no data is duplicated? Answer: transport. Question: which uses acknowledgement to verify that packets got delivered at its destination? Answer: connection-oriented. Question: which is faster, connectionless or connection-oriented? Answer: connectionless. Question: what does an IP address and a port number together define? Answer: a socket. For more information, visit the following sites. In summary, the transport layer is responsible for providing reliable data transfer services to the upper layers of the OSI model. The unit of measurement used on this layer is sometimes referred to as segments. Connection-oriented communication establishes, maintains, and terminates dedicated virtual connection between devices to ensure the data is delivered in the correct order and without duplication. Connectionless communication provides connectionless services where each segment is treated independently without establishing a dedicated end-to-end connection. Multiplexing allows multiple applications to use the same network connection simultaneously by assigning unique port numbers to different applications. A TCP/IP port number is a logical connection placed by client programs to specify a particular server program running on a computer on the network defined at the transport layer. A socket is a virtual endpoint of the two-way communication link that acts as a communication channel between two applications on different devices, allowing them to exchange data over a network. Essentially, it's a logical address that combines an IP address and a port number to uniquely identify a specific application on a host, enabling data transfer between applications on different computers. Thank you for watching this video. The next video will be Networking Concepts, Part 6, OSI Model Upper Layers. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.